So we have a very last slot today. So I was just saying before how grateful we are for all our sponsors this year. And in particular, we will have talks today and tomorrow from our gold sponsors, giving us an overview of their vision for SEL4 in their own organizations, which will be a great way to have a bit of an overview where this is going. So it's my great pleasure to introduce Boyd here, who's the founder and CEO of Kry10, and that will give her the vision from Kry10 for SEL4. Thank you.
Okay.
Thank you.
Hi, I'm Boyd. So I'm like used to doing keynotes and all that, and I got 15 minutes. So I'm going to kind of get right to it. Lots of discussion today about assurance, about kernels, about operating systems. My mission in this talk is to give some context and help us all understand which pieces are appropriate for what kinds of problems and what aren't they. So in that, I thought I would start by let's talk about where do static, semi-dynamic, and dynamic systems live, because to me this is contextual importance. In the upper left-hand kernel, so in this chart, I've got how high is your assurance requirement versus how complex is your mission. This is not how complex is your OS. This is how complex is the mission of a device. In the upper left-hand corner is where Secret Squirrel lives. I'll give an example, and I don't actually know because it's Secret Squirrel. But if I had, say, a classified network and I wanted to build a VPN talking out over the public internet, I would want a very simple device with a very clear information flow, and I would want that to be static, and I would want to have complete control over it. You know, that's never going to be dynamic in any way. In the other side, if I have a laptop, and at the time I make it, I have no idea what software you're going to put on it. I have no idea which apps you're going to want to run when. Is this going to be a PowerPoint presentation? Is this going to be Baldur's Gate 3? Is this going to be Word? I don't know. So this is a fully dynamic system. But the price I pay for that is I'm not going to get a huge amount of assurance, right? That laptop is vulnerable to viruses and other attacks, and there's very little in its inherent design that would prevent that. On the left side is where I would put, let's call it classic IoT devices. There are devices that are very small. They do a thing, they never get updated. That's great. You know, there's a huge number of those kinds of devices, and they should probably be static. Putting something of any amount of dynamicism on it would be overkill for that scenario. But there's a huge section in the middle of things that need assurance, but they also need to be updated. They run for a long period of time. Because they run, the policies on them change, the use cases change, and they have to be live, they have to work in a real-world environment, but you also have to trust them. That's where the semi-dynamic world lives, and this is effectively the story that Kent and Ihor and Matt have been telling today through their talks, is how do you approach a semi-dynamic system that delivers both assurance, but also gives you a device that you can put up on a satellite, or you could put it up on a pole, and you don't have to physically go to it, but you can continue to have it work in its environment. So this is where Kry10 lives, very clearly here. And part of why I'm not worried about all the other system options that are about is, frankly, I don't think we overlap. I think we're going after different scenarios. Okay, so we've seen variations of this all day through various talks. I've talked to so many customers. I've talked to people in automotive. Spent a lot of time talking in automotive. Spent a lot of time talking to people in industrial control systems. This is both from running a factory to communicating to a factory. Think about a water pump. Think about all these different systems that get deployed in the real world. And the three things that I've come to believe are required for a successful semi-dynamic system to work are, it's got to have great protection. It's got to be resilient to failure, meaning, look, software engineering isn't a thing, it's an art. The only place I've ever heard of software engineering that you can believe is software that's been verified. Most of the code out there isn't. and it's got to have a real-world life cycle. Like, what's the number one pushback I get when I'm talking to real customers and you say, hey, here's this new system, it's got assurance, it's got all this. What's the number one requirement that I hear? How can I hire anybody who can do it? That's a life cycle problem. How do I hire people? How do I get the expertise? How do I have tooling? How do I maintain it? How do I integrate it in my OT system? That's life cycle. Now, after doing this for a while, I've come to realize there is an order of inheritance here. If I want to have a real resilience story, I mean, I can go look at Erlang and I can go learn from Erlang, but at the end of the day, Erlang itself is sitting on cottage cheese, right? It's sitting on a fully dynamic system that is still vulnerable to all the different types of failures that we're here today talking about. If I really want resilience, I need to be able to have that protection piece nailed first. Then I've earned the right to have a resilience discussion. Likewise, for life cycle, if I'm talking about maintaining a device, if I'm talking about the continuum of develop, integrate, test, deploy, and as soon as you've deployed to the field, you're developing and integrating and testing again, and it never ends. If I want to have a real discussion there, it depends on a good resilience story. So you have to build this in order, and you have to get the whole thing, left to right, done, or you aren't really giving a solution in the real world space of complex devices. I'll go through this really quick here. So protection, this is what we're talking about today. The first three things, having verified code, fixes bugs, isolation, verified deletion. By the way, a huge percentage of the code in SEL4 is about deleting things. It's about cleaning up UT. The fact that that path is verified is huge, and we don't talk enough about the implications of it. Because what the combination of those things mean is I can build a software bill of materials that is believable. The rest of the software industry is talking about SBOMs, but it's not a software bill of materials. It's a software hope of materials, right? Hey, these are the apps I want, and I really hope that's what's running. But without policies, without assurance, you can't build a believable software bill of materials. So that's required to have this discussion, and that's, I think, where a real statement about protection starts. Now from that, once I have a believable SBOM, now I can talk about resilience. Now I can talk about supervised recovery systems. What do I do in an error? That's what Ihor is talking about. I can talk about, hey, this app went down, but this one, I want to keep it up. How do I reconnect them? That's a dynamic session. But take those together, the mission here is minimal downtime. If this is a device that's running the water pump that delivers to your neighborhood, you don't want it to go down. Its policies are being updated. It's under attack. When there are errors, you want them to recover, and you don't want the pump to stop. But really, this life cycle thing is hard. I need to hire people. They are not in this room. This room represents a significant portion of the population on the entire planet that knows what SEL4 is and how to code to it. I need the next 10,000 developers who may be building websites. They may be using robot operating system. Maybe they know Elixir and Erlang. We have to bring them into the discussion. So that means I need familiar environments to them. I've got to have composable libraries. Every other system we've ever talked about, like if I look at Node, if I look at Elixir itself, if you look at all these other systems, they've got package managers, right? They've got formal ways to share code between people, and it just sort of composes together. In this world, composition starts at the software bill of materials. We can't compromise on the policies. We can't compromise the insurance. That means composability requires developers of a driver are also including policy. They're including resource requirements. They're including signatures. They're including licenses. And most of all, you got to have services where you can actually talk to these devices remotely and update them and keep them alive. So really high-level view, everything we've been talking about, Yeah, we are all in on SEL4. That is the root of that verification and that policy system. That's what gives you the protection. But you've got to have a manifest or software bill of materials that is believable. And it's not just which UTs and which capabilities, it's also restart policy. These two apps are linked. If one goes down, restart the other one. These two apps have a dynamic relationship. If this goes down, keep the other one up, but re-establish the connection, that kind of thing. Those services are written in the Kry10 OS services. Ihor mentioned the error kernel. That would be that piece, right? This would be like your error kernel. This is your system above the kernel, the core kernel, which is providing things like restart and knowing what to do in the event of an error. And then you've got a pile of applications that are running, and you have to support the environments people expect to be coding in. So today we've got Beam, Rust, C, Elixir, full Erlang support, partly because it's so good at error recovery. We've got plans to do Python, which means robot operating system. We've got VMs that we're already working on that you can spin up. Hey, you need that driver, and it's only in Linux. Go ahead and spin it up. But the danger in VMs is that you're going to want to put the whole thing in the VM. So really, to me, a VM is an escape valve. You put the driver you can't get anywhere else in that, you hook it up to the other pieces, but it's through that separation that you're able to have a system you can believe. Okay, what's our roadmap? Now, I recognize that we've been talking about this for a while, and that people don't necessarily have full access to it. This is hard to build. The semi-dynamic system is difficult to wrap your head around. So we've been working hard with some very close partners, and that model will tend to continue. We've been talking to some really good ISVs who know what they're talking about, and when they have projects, we're ready to work with them, but we have to have enough support ability to be able to get systems that can be of a commercial quality. So one of the decisions that we've made is that we're going to go with a major minor heartbeat. So from now on, you can expect that in November, December, we're going to do minor releases. In June, July, we're going to do a major release. And then there's an optional, think April, May release. I just want that to be a heartbeat. Every single year, you always know there's a major release. And then you pick the release that you're building on, and that one will be the thing that is consistent. If you pick the next year's major release, you might have to port. Okay. So this year, we're getting our virtualization up. We're doing a huge emphasis on usability, documentation, tooling that just manages that manifest for you. This release is a big one. This is the first time I think the full tool chain is actually there. Getting composable libraries and a library manager is a big deal. I want to be able to just point to a driver from someone else, pull it in along with its policies, along with its restart policies, along with its resource usage, and it just works. I do want to very briefly say this has been a difficult year for all startups, and we've been really lucky. So I want to thank Folklore Ventures and Movac Ventures, so Sydney and New Zealand based. We've got some great partners who are with us all the way. We are in. Down at the bottom, we've got some partners that we're working with on the development side. So expect some announcements in the March timeframe around Erlang solutions and some actual projects that are happening there. Maybe a little lower on the assurance side of that chart, but higher on the complexity. We're working with companies like Codasip and Idaho Scientific to also have a good hardware solution that backs up the software needs. So think, there's things you can't just, there's situations you can't fix in just software. You have to have hardware-software co-design, and working with people who are actually working on next-gen RISC-V processors is absolutely what you have to do. Now, if you're interested in working with us, what do you do? Well, okay, we are still in a mode where we have limited ability to support. We're growing, we're building, and we're working with very close partners. So right now, the projects that we have, frankly, they tend to be more government-oriented. because they require a lot of hand-holding from us. But after December, with the emphasis on the usability, that will get easier. We'll start to see more ISVs doing projects that they're running independently. And then after June, July, that's when things start to scale. Now, how open is that going to be? Meaning, how wide of a net are we going to do to work with everybody is to be determined. It depends on some of the usability pieces. But we are absolutely moving this thing ahead and constantly engaging a wider net of people. And I have been really conscious about my time, so I'm going to say thank you, and maybe there's 30 seconds. I don't know.
Thank you very much, Boyd. We'll take the time for 1 or 2 questions.
Okay, so the question was, hey, I'm an American. It's true. I grew up in Wisconsin. I spent half my life in Seattle. And I've moved to New Zealand. Lots of reasons why I did it, and that's a story we can mostly talk about afterwards because it involves spreadsheets and statistical models and my wife being a data scientist and all that stuff.
It's very interesting, but for drinks, just go for the drinks.
There is funding from the US, but for now it's small. There are other funders who are in the US who don't want to be named at this time. And expect that to particularly grow the next time we go through this exercise, which will hopefully be in a couple years.
Hi, so you mentioned the SBOM problem. And is that something you're looking to explicitly chase after to say, here's a better solution, here's a real SBOM that's not just aspirational, but reflects what's actually being shipped and delivered to you?
Yep.
And then run and maintained?
Yeah, great question. I don't think it really came through today and across the various talks. We call it the manifest internally. It is an SBOM, and it is the core artifact at the center of the system. It's the thing that drives the policies that actually get built by that OS service engine. It is, I do believe it is a next-gen version of software bill of materials because it's backed by the formal policies and it relates directly to them, and it relates to the systems that are above it doing the restarting and keeping the system up and alive. I really honestly believe if you're doing SBOM work on top of systems that aren't backed by formal methods, it's really an exercise in hope. And we need more assurance than that for most of our devices. Maybe not some of the scenarios around PCs, but certainly in everything else. And you can get that in 2 ways. You can build a completely static system where you can do analysis after the fact, but now you're limited in the amount of complexity and the uptime and updating. Or you can build something that's semi-dynamic and you have to build other systems around it. But I absolutely believe that a next generation SBOM is required.
So I had a follow-up to that. So
Yeah.
Does that mean you mean to provide, let's say, an attestation service that would say, okay, you give me your SBOM, and then I can say, are you still running the same code? Can you provide me evidence as your system is evolving that it maintains that bill of materials that you told me was what your system was built from?
Yeah, great question. How do you do the attestation on it? Is there an attestation service? I'm going to answer it in a couple ways because this part's not completely done. This is some of the work that's in more that June, July timeframe. But a little bit of background, I came from the game console world. Attestation is actually extremely important in that world because that's how you know someone has purchased a title. That's how they know that that's how you know that they're not, playing stolen content or cheating to win or that kind of stuff. Absolutely, you need to have attestation. You need various levels of cryptography to go and do it. You effectively need to have certificates that cover the whole range. That includes the libraries that I'm composing in. I want to know if I'm choosing that driver from this company, I want to know that they signed it and that someone else didn't go and inject a source code attack as some kind of supply chain issue. Right? So I want to get attestation all the way up and down the chain, and I can point to a device, I get the hash of its manifest, and I can pull up everything that was associated with it, right? With the cryptographic evidence. That's where this is going.
Join me to thank Boyd again. Thank you.